Good morning everyone, welcome to my video. In this video I'm going to talk about RIP. My name is Yap Chee Yuan. I'm the instructor for InfoSight. So let's start the lesson. So what exactly is RIP? RIP in short stands for Routing Information Protocol. RIP is an IGP, which means that it's an interior gateway protocol that running on distant vector algorithm. We have another algorithm which is the link state algorithm. Alright, so RIP is a distant vectors algorithm. RIP is mainly used in a small scale network and do not require high reliability. And is seldom used in a large and complex network. So if you intend to run some protocol on large and complex network, you should be running on OSPF or RSIs, which we are going to discuss on the few topic later on. Alright, so we focus on the RIP. We will look into RIP principle. We look into the RIP configuration, the RIP troubleshooting, as well as the enhanced capability of RIP. And we will also look into the RIP exam skill that is needed for you to pass your HCIE exam. So the content for our topic will be looking into the principle, the command, troubleshooting. We are going to discuss two cases on the RIP and look into the exam preparation. So first, we look into the principle on both RIP version 1 and version 2. We look into RIP timer. We'll look into some of the concepts such as a split horizon, poison reverse, and trigger update. And we will look into the route summarization, which is very important. And finally, we will combine all the RIP working process together. Let's first look into the RIP version 1. And even though RIP version 1 has been quite some time, let's look into the concept. And this is how the packet format of RIP look like. Now the top here, this will be our header, okay, which is in this case the command as well as the version. The command here we have two values, okay, so we have value number 1 or value number 2, which value number 1 refer to a request and value number 2 refer to response. Okay, so we only have two values here. The version is either version 1 or version 2. This view is mainly as 0, not being used. We have address family identifier. Okay, this is for you to determine whether it's an IPv4 or whether they would like to request the entire routing table. So there are few values over here. If it's IPv4, it's a value of 2, and if you request for the entire routing table, it's a value of 0. This is not being used. So the IP address here is the IP address of the destination network. This two field is not being used, and the metric is the hop count that is used on the RIP. So generally, RIP is a classful routing protocol, which means that they will only look into the IP as a classful, like class A, B, and C. RIP version 1 use the broadcast mechanism for them to contact their neighbor. They are using UDP port 520 to send and receive packets. Now let's look into the RIP version 2. In RIP version 2, the format is similar to RIP version 1. Okay, except that you notice that there are some new fields. So route tag is a new. The subnet mask is a new field, and the hop count is a new field, the next hop. So the route tag is being used to determine whether the route has been imported into the RIP through the import command. So this is a subnet mask. As you notice that RIP version 1 doesn't have it because RIP version 1 is a classful, whereas RIP version 2 is a classless. So we do have a subnet mask information. We have a next hop here. If your next hop value is 0.0.0, means that optimum net hop is achieved. Else, that is not the optimal net hop. And the metric is similar to RIP version 1. Now, RIP version 2 uses 224009 instead of a broadcast for them to do update. they're using the same UDP 520 to send and receive packet. Now, as compared with RIP version 1, RIP version 2 has enhanced in the sense that they do support route tag, route summarization, CIDR, classless inter-domain routing, next hop, as well as authentication. And surprise, surprise, you notice that there is no authentication field over here. So there's a question here. Why do RIP 2 version 2 packet do not have authentication? Now, it all depends on your address family identifier. If you do have authentication field, this address family identifier will actually use to cater for the authentication. Okay, so we are going to look into some of the Wireshark capture for us to look into more detail. Okay, let's look into our Wireshark now. So here I have my Wireshark. So both version 1 and version 2. This is a version 1 Wireshark. As you can see that I have the response and I also have a request. Now if we look into our protocol here, you'll notice that we are using UDP port 520. And since this is a version 1, as you can see that this is a version 1, you'll notice that the method for them to communicate among RIP is using a broadcast. If I expand the routing information protocol, you'll notice that the header, we have a response, okay? And if you look into the request, you can see that the value is 1. We have a value of 1 here, which representing the version is version 1. So this is our address family unspecified, which means that we want to get we're requesting the routing table. And there's the matrix. Okay, so this is our request. So we also have a response here. As you can see that the response here, we have the address family of IP, which is the value of 2. Okay, so this is version 1 on RIP. As you can see that the information here is pretty simple. Now, as compared to version 2, this is a version 2. And you notice that the version 2 is still using a UDP of 520. And they are using a multicast of 224009. Okay. Now, if I expand the routing information protocol, you notice that the format they are using is the same. So we have a command, we have the version. And if I expand the IP address, you notice that I have an address family. This is a new format here. Okay. The route tag. As compared to version 1, I do not have a route tag. This field is 0, meaning that they do not have any external route at this moment. I have a network mask here, as well as the next hop. Alright, now these are the difference between a version 1 and version 2. So let's just go back into our slide here, and let's continue the next slide here. Let's look into the timer on RIP. Now RIP is being regulated by 3 timers. The first timer is an update timer, second timer is aging timer, and the third timer is a garbage collect timer. Now what's the relationship between these 3 timers? So let's look into the detail of the timer on how the mechanic works. Now for example, I have R1 and R2. So these R1 and R2 are running both RIP, regardless on RIP version 1 or version 2, the mechanic is the same. Now R1 send an update to R2. Now upon receive this update, R2 is going to start the aging. Now the aging is going to count from 1 second all the way to 29. Now by the 30th second, the R1 should have a new update to R2. Now assuming that due to some reason, this update is not reachable to R2. Now R2 is going to continue the aging until 180 seconds. Now during the process of aging from 1st second until 180 seconds, this route is okay, it's still reachable. Now by the time of 181 seconds, it will go into the garbage collect timer. The hop count is become unreachable. Okay, so
When we reach up to a 300 second, which is another 120 seconds from the aging timer, and when it first start go into the garbage collect timer, it will become unreachable, and once they go up to 301 seconds, it will go into delete. So in another word, when the aging from 1 up to 180 is reachable, from 181 to 300 seconds, this route is unreachable but is still inside the database. Right? So these are the relationship on all these timer. Now let's look into the split horizon. Now definition of split horizon is a method of preventing routing loop by prohibiting device from advertising a route back to the neighbor through the interface that received the route. And split horizon is disabled by default if you are using NBMA. Now let's look into this example. We have R1 and R2. R1 have an interface of 10.00/8 attached to it. So 10.00/8 is a hop count of 0. Now R1 send this information, this update sent to router 2. Router 2, when it receive it, it will see this route as hop count of 1. Now if let's say the RIP on the R2 do not have a split horizon, it's going to send this information back to R1 to say that, hey, R1, I have a route of 10.0.0.0/8, and the hop count here is 2. Now, assuming that R2 also have connection to R3, it will also do the same thing, telling R3 that if you want to go to 10.0.0.0/8, you can go through me, and the hop count is 2. Now, assuming that that's happened, and assuming that R1 now lost the 10.0.0.0/8, and assuming that the split horizon doesn't work, so in this case, they do send back this information to R1. Now, R1 would think that, hey, I'm able to reach to 10.0.0.0/8, and my next hop here is R2. So I'm going to believe this update. Now, because R1 received this update and R1 also directly connected to R2, and R1 is going to add a hop from 2 plus 1 is become 3. Okay, saying that, hey, R2, if you want to go to the 10.0.0.0/8, you can come through me, and the hop count is 3. Now, R2, upon receive it, looking into the update, and the next hop is R1, and what it's going to do here is that it's going to add this from 2 to become 4, because since I received from R1 as 3, I'm going to send to R3 as a hop of 4, and I'm going to send this information to R1 as a hop of 4, and that is where the loop happens. Alright, so for us to prevent this loop, split horizon has to be enabled. Poisson reverse is a method of preventing routing loop, just like split horizon. But the mechanic it's used to do a loop prevention are slightly different. Now, they are sending what we call a poison, which is a hop count of 16, indicating an unreachable route, and advertise the route back to the neighbor. And poison reverse by default is disabled. Okay, so in this example, R1 send this information to R2. This information of 10.0.0/8 is a hop count of 1. Now, upon receive this information, where R2 enable for poison reverse is going to send this information back into R1, saying that the cost is 16. Now, when R1 receive this information, it will going to delete this information from the update. It's because that the cost is 16. All right, so the loop is prevented. All right, because I do not believe that R2 have the hop to the 10.0.0.0/8. So when both poison revert and split horizon are configured, only poison revert will take place. So please remember that under Huawei device, split horizon basically is enabled, and poison reverse is generally disabled. All right. Now, trigger update. Trigger update is a mechanic for you to shorten the network convergence time. And this is how it works. When the routing information changes, for example, in this case, the network of 10.0.0.0/8 attached to R1 changes from up to down, the RIP device is going to send this update to the neighbor immediately, which means that if, let's say, R1 just sent this information, let's say 2 seconds ago, and when this interface go down, it will not going to wait for another next 28 seconds before it's actually sent. It will never wait. It will just send immediately. Okay, so this is what we call the trigger update. And by doing so, you will reduce the time for the waiting, because if it's not, you are going to wait for 300 seconds before the route will be deleted. So trigger update expedite the convergence time. But over here, it's also mentioned that trigger update does not enable a device that received the route update to reset its update timer. So which means that this information of 10.0.0.0 is failed. Now R1 is going to send this information to R2. Now R2, upon receive it, this information will not be trigger update to R3. Okay, so a trigger update is only happen between R1 to R2. Now, one of the powerful features of RIP version 2 is that RIP version 2 support summarization. And as we know that the summarization is very important. Routes that share the same next hop are destined to different subnet on the same natural network segment are summarized into one route that's being advertised to other segments. So in this example, we have 10.1.0.0 and we also have 10.2.0.0. Both of them are /16. Okay, now we can summarize based on the interface to use a /8 to R2. So R2, instead of having 2 entries, now they only have 1 single entry. So the summarization only can happen if you are using a version 2. And the version 2 process-based classful summarization and interface summarization are available, which means that you can summarize based on interface, or you can configure based on the RIP config. Now let's look into the summary on how the whole thing work altogether. Now initial state is that when you start RIP, it will go into the initial state. And whichever interface that you have enabled the RIP will start to send or receive RIP. And RIP will build its routing table. So under this building routing table status, your RIP will be stable. Now, during this process, I'm going to send and receive this routing update for every 30 seconds. So the entire routing table will be sent and received for every 30 seconds. If everything is fine, all right, the whole routing table will be stable. Now, assuming that the routing entry is more than 180 seconds, it will go into the garbage collect entry, and another 120 seconds, and it will go into the delete entry. Now, assuming that you have an entry that is attached to you and it go down, it will go into the trigger update. Now, once trigger update happen, it will go into the garbage collection, and 120 seconds later, it will straight away deleted. Now, if the condition of your route is under the garbage collect entry, that's the status, and you are still in the aging timer, but it's between 180 to 120, 180 and 120 garbage collection time, and assuming that the update came, now it will restore back your entry into your routing table. Okay, so this is the entire working process on RIP. So let's look into some of the configuration. Over here, I have a simple lab to illustrate some of the basic concept that we went through just now. So I have R1, R2, and R3. Which R1 connect to R2 through the serial interface, having a network of 10.0.12 network, and R2 to R3 having a network of 10.0.23. So if I go to the display IP interface brief, you're able to see that I have a 10.0.12.1, and if I go to R2, I have both the interfaces. Okay, the interface that's facing to R3 is gigabit, and the interface that's facing to R1 is a serial interface. Let me do a test ping. All right, so that will be an R1, 10.0.12.1, and let's do a ping to 23.3. Now, each of these router have its own loopback interface. So if I go back to R1, you notice that the loopback interface is 1.1.1, router 2 is 2.2, and router 3 is 3.3. Okay, so let's just start the RIP, a very basic configuration of RIP. I'm going to start to use a version 2 because version 1 is pretty easy. I'm going to use a network 10. Alright, that's it. So we are going to do the same thing throughout the routers. Now what I'm going to demonstrate over here is some of the display commands. So it's very important for you to check if your RIP is running. So when I look into this command called display RIP1, you'll notice that the timer, we have the update timer of 30 seconds, H timer 180 seconds, and garbage collection timer of 120. And by default, you'll notice that we have some interfaces over here. Okay, so we are going to look into the interface. If we look into the display RIP1 interface, let's look into the interface S100. I'm going to look into the verbose. And you notice that the poison reverse is disabled, okay, as speed horizon is being enabled. That's the default. And if you still remember the concept about the speed horizon, if R1 sends this information to R2, R2 will not send this information back where the interface came from. Okay, whereas poison reverse mentioned that if you are going to send this information to me, I'm going to poison you with a unreachable metric of 16. So we are going to look into some of this configuration. So by now I should have the route of 2.2 and 3.3. Let's have a look. Display IP routing protocol RIP. All right, so I have a 10.0.23. This is the network, but I have not receiving number 2 and number 3. The reason is because that I have not enabled the network 1, 2, and 3. So let me enable the network 1 here. I go to router 2, network 2. And number 3. All right, so the update should have received. Okay, so let me do a display IP routing protocol RIP. So I have number 2 and number 3. Now, one way for us to check on our route aging. So the command for you to do here is display RIP1 route. As you can see that 2.2.32, my next hop is 10.0.12.1. And you notice that R stands for RIP, A stands for its aging. And if you still remember, the aging will last for 180 seconds before it go into the garbage collect. So this timer indicates that it's just received about 1 second ago. And you notice that 24 seconds, 26 seconds, 28 seconds, 29, 31. And you notice that it will go back into number 1. By right, it should be going to 30 seconds maximum. So plus and minus some of the timers. So we have here, the timer go back to number 1 again, as you can see from here. Okay. And if I go into number 2, it will be exactly the same. Display RIP1 route. There you go. All right. So we have number 1 here, network number 1, and network number 3. And you notice that the updates are slightly different because the update from R1 to R2 and R3 to R2 are at a different time. Now, for example, let's just configure our speed horizon. And before we actually do that, okay, let's check our Wireshark. So I start my Wireshark on the PPP here. And what you can see is my RIP version 2. Okay, so you can see that this is at 1 second. This is on the 10.0.12.2. So on the 31st second later on, I should see another update by 10.0.12.2. All right, so I'll just wait a little bit more. There you go. So you can see that this is 10.0.12.2. This has happened on the 28th second. All right, it's fast, a little bit faster than what I'm expecting. So this is 11. So at 11 second, and I plus another about 30. So it should be about 31. So you can see that this is slower than what I'm expecting. Right? Okay, so I'm going to do a split horizon. As you can see, the split horizon has been enabled. So if I go to the serial 000, interface serial 1000, I'm going to do a RIP split horizon. You will notice that the split horizon has been enabled. So I'm going to undo the RIP split horizon. Okay, so what will happen over here is when I do a display RIP1 interface serial 1000 verbose, you'll notice that the split horizon has been disabled. Now if I do a wire shout, okay, so you notice over here, what happened here is that when I do a information sending, 10.0.0.12.1, I'll send to 10.0.12.2. You'll notice over here that this information is being sent back to me. And if I go into the information here, you'll notice that I have a metric. All right, so you can see that this is what 2 sent to me. So when the router 2, 12.2 sent to me, it sent a 2.2.2 metric of 1, which is true. If you look into my network here, 2.2 is here. It sent to R1 as a hop of 1. Now, surprisingly, after I disable the split horizon, what you can see from here is you notice that number 1 send this update back to number 2. So the source here is 10.0.12.1. And if you look into the network here, you'll notice that the 2 network is being sent out with a metric of 2. Okay, so this is what happened when we disable the split horizon. So when 2 send this to R1, R1 is going to send back immediately to R2. So for us to prevent the loop, all right, this one's supposed to be enabled. Now what will happen if, let's say, the interface of R2, now we remove it. So if I go into the interface loopback 0, okay, let me show you here. This is 2.2. I'm going to undo interface loopback 0. So now this interface is gone. So if I go back and have a look, all right, now you notice over here that there's some sort of a loop actually has happened. Okay, so you notice that I have here 10.0.12. Okay, and you can see that I have a metric of 16. Okay, so this is our loop prevention. Now because that I'm actually sending out this information, you notice that this information is actually being updated by 10.0.12.1. Okay, 12.0.1. You notice that they actually send out a metric of 16. All right, for us to see clearer, let's just do a filtering. Okay, so I'm going to do a filter based on RIP. Now, when I shut down the interface on the loopback just now, you can see that this was by 12.2. This is before I shut down the interface or remove the interface. You can see that it actually sent out a metric of 1. And because the split horizon has disabled, so R1 is sending back this information back to R2 saying that the metric is 2. Now, right when I shut down this interface, as you can see that this is still number 1 of a metric. And on this frame, you notice that this is where I actually shut it down. So at the 350 second, you can see that the network of number 2, okay, is actually a metric of 16. It actually is a trigger update. You notice that? is a trigger update. Immediately it's actually sent out saying that 2.2.2 is 16 hop. Now upon receive a information of the hop is 16, you notice that because the speed horizon has been disabled, router 1 is also sending out the metric as 16. Okay, this is prior that it received, and this once it's received is actually sent out as 16. So this is a trigger update and is being poisoned by R2 saying that the route is unreachable. So a hop in reality never appear. Okay. Next, I'm going to show you the poison reverse. So we go back to R1. As you can see that the speed horizon still has been disabled. So assuming that I will just let it disable and I go back into the serial 100, I'm going to do a RIP poison reverse. Okay, so with the poison reverse has been enabled, whatever the R2 advertised to R1, R1 is going to poison back to R2 with a metric hop of 16. So if we are going back into our Wireshark, okay, and we are going to monitor it. All right, so what you can see from here is our Wireshark. Okay, so if let's say we go in and have a look on R1, you notice that the R1 with the poison reverse enable, you notice that actually send back a metric of 16. All right, the tree network is a metric of 16. So this is where the poison reverse has been enabled. Okay, so if let's say I have enabled speed horizon and the reverse poison reverse will be having a higher priority, will take precedence. So if I do a display RIP1 interface S100 with a verbose, you notice that the poison reverse has enabled. All right, so let's look into the trigger update now. So if I in the R1 I do a display RIP1, as you can see that we have our update time of 30, aging time of 180, and garbage collection of 120. So for me to demonstrate the trigger update, I'll go to R3 and I'm going to do a removal of the interface of 3.3. As you can see that the interface of loopback is still available, and in R1 if I do a display IP routing protocol RIP, you notice that I have 3.3, and when I look into the timer on the aging, you can see that it was 13 seconds ago being advertised by router 2. Now trigger update work when the interface go down, it will send this information straight to the next router, and this is what happens. So if I do removal of the interface, undo interface loopback 0, press enter, and I go to R2, display RIP1 route. Okay, so you can see that it's straight away going to the garbage collection, and the aging on the garbage collection start to count down. On R1, you notice that it's also going to the garbage collection, and this is the aging. And once you go up to 120 seconds, this route will be deleted. Okay, so we will wait for the 120 seconds, and definitely I'm going to pause this, and I will continue before it reach up to 120 seconds. All right, so closer to 120 seconds, so you can see that now it's 120, and immediately this route is being deleted from my routing database on R1. Okay, so what you can see here is that the garbage collection as well as the trigger update. So I'm going to reinstate back the route. Okay, so once I reinstate back the route, and I'm going to have a look on the entry. Right, there you go. All right, so the entry has been propagated and it has been reinstated back, and it starts to do aging again. Okay, so you can see that this has been updated from 10.0.12.2. I'm going to do an authentication between R1 and R2. So we are going to do the RIP authentication. Alright, so I'm going to do a RIP authentication on R1, R2 and see what will happen on our Wireshark over here. So let's go back into R1 in the serial 100. I'm going to do a RIP authentication mode. I'm going to use an MD5 and I'm going to use the usual format. I'm going to use a plain, as in the plain format when we do a display current. I'm going to do an Huawei. Okay, so remember that I have this authentication. And you notice that I have a 1.1 over here. Now, because the authentication between R1 and R2 are different, so R2 will not receive the network number 1 after a while. So if I do a display RIP 1 route, as you can see that the second now is already aging up to 34 seconds and it go into 40 seconds. And you still remember that our update timer should not more than 30 seconds. Now anything between 30 seconds and 180 seconds, it will actually go to the aging. Okay, as you can see that now I have up to 54. But this route is still valid. Okay, as you can see that I'm still able to ping. And it will become invalid when it hit up to 180 seconds and above. So if I just do one more time on this, you can see that it's still in aging mode. All right, 68 seconds. So I'm going to pause this video and I will come back to you when it's closer to 180 seconds. Okay, so the route already aged up to 132 seconds. And one more thing that I want to show you here is when R1 have this authentication between R1 and R2, as you can see that I'm still able to ping. All right, I'm still able to ping to the network. And you will notice that between R2 and R3, you will expect that the R2 doesn't send this information to R3, which is not. You notice that the most recent update was 2 seconds ago. So in over here, the update that is not received by R2 between R1 and R2, R2 will still send this information to R3. So now let's see our aging here. And almost come to 180 seconds. And now it go up to 180 seconds. You notice that it go into RG. So now if I'm going to do a ping to 1.1, you notice that it's unreachable. All right, because it's in garbage collection. And when I go to R3, and you notice that now it's actually going to the garbage collection. So when R2 doesn't receive this information and is actually going to the garbage collection, then R2 in return is going to send this information to R3. So after another 120 seconds, this route will be removed. So for me to reinstate this route, I need to use the similar authentication. But before I go to the authentication, let's have a look onto our Wireshark. So if you look into the Wireshark, you notice that there's such information saying that is a malformed packet. Now, if you look into here, there's a difference on the version 2. In version 2, you notice that right now I have a response. I have here the RIP. You notice that there's an authentication key. As compared with 12.2, I do not have authentication. You notice that I have an address family. All right, this is what I mentioned early on in my slide. This address family is being used as an authentication. Okay, and right now they weren't able to authenticate not able to authenticate each other. So for me to make sure that they can authenticate with each other, I go to the R2 serial 100/00 RIP authentication MD5 usual. I'm going to use a plain Huawei. Sorry, it's Huawei. Okay. So once you have configured properly, when I do a display RIP1 route, so we just wait for the route to be propagated again, you're able to see the 1.1. There you go. All right, so that's conclude our lab on the authentication as well as the trigger update.